Hello, welcome again. We are covering the subject thermodynamics for civil services means IFS and various gate exam. The next topic in the chapter of entropy is entropy transfer with heat flow. So since we know that ds is equal to dq reversible by t, so when the heat is added to the system, dq reversible is positive and ds is also positive. So it means uh, entropy will increase when heat is added to the system. So when heat is removed from the system, dq reversible will be negative and ds will be negative, so entropy will decrease. So entropy is somewhere associated with heat transfer, because heat transfer increases the internal energy of the system, which results in higher kinetic energy of the molecules. So molecules will collide more frequently, and there is more disorder in the system when the molecule collide more frequently. So that disorder is your entropy. Okay, so heat is thus can be regarded as disordered energy transfer. Okay, which increases molecular collision, molecular code. Okay, so I will read this out. Heat transfer to a system of fixed mass increases the internal energy of the system, as a result of which the molecules move with higher kinetic energy and collide more frequently. So disorder in the system increases. So heat is thus regarded as disorganized or disordered energy transfer, which increases molecular force. So that molecular force is your entropy increase. More the molecular cause, more will be the entropy. Okay. So now if we take an example for this is your system which is maintained at temperature T naught, and this is your surrounding, it is also at temperature T naught, and heat is being transferred from the system to the surrounding. So as heat is being transferred to the surrounding, so the surrounding entropy will increase, and the surrounding entropy is q by T naught. Okay, and system entropy is minus q by T naught. System entropy will decrease because heat is removed from the system, and system is also at T naught, so entropy decrease of the system is minus q by T naught, and entropy increase of the surrounding is q by T naught. So as both are same, so entropy of universe is zero. So this is this is an reversible. This is a reversible process. So this is q by T naught. This is also q by T naught in magnitude. So if we add them, the entropy of universe will be zero. So this is a reversible process. So we can say that the entropy has been transferred from the system to surrounding. Okay, and system, or we can say that system has lost entropy and surrounding has gained entropy, and this is occurring with this heat flow. So, and it is also a reversible process. Even in a reversible process there can be entropy transfer with heat flow. Okay, so entropy is being transferred with heat flow. Okay, reading this out, if heat q flows reversibly from system to surrounding at T naught, then the entropy increase of surrounding is del S surrounding is q by T naught. The entropy increase of the entropy of the system is reduced by change in entropy of system minus is equal to minus q by T naught. Okay, the temperature of the boundary where the heat transfer occurs is the constant temperature T naught. So this is your constant temperature T naught. It may be said that the system has lost the entropy to the surrounding. Alternatively, one may state that surrounding has gained entropy from the system. Okay, therefore there is entropy transfer from the system to the surrounding along with heat flow. Or in other words, we can say, since the heat inflow increases molecular disorder, there is flow of disorder along with heat. Okay, so now we have studied that the entropy is transferred with the heat flow. But if we take work, with work there is no entropy flow. If we consider this system which is delivering work to the flywheel will start rotating. But this rotation will be the organized rotation of each molecule. Okay, each molecule, the respective distance of the molecules of the metal of the flywheel will not change. So there will be no disorder. So that is the energy transfer without any disorder of the molecules of the flywheel. So there will be no entropy transfer. Similarly, if we take the case of spring, suppose this is here we supply work and the spring gets compressed, then the each molecule of the spring will be compressed in an organized manner. Okay, there will be no respective change in order of the order change in order of the molecules. Okay, so there will be no entropy transfer with the work. But if we suppose if we transfer work by this shaft to this fluid, when we transfer work from the shaft to the fluid, the fluid will start rotating. Here the respective distance between the molecules of the fluid will change, which will cause increase in temperature or increase in internal energy or increase in disorder of the molecule. So that will cause change in entropy. Okay, here work is being converted into heat, and heat is then causing change in uh, internal energy, and which is causing increase in entropy. And we are considering that there is no heat outflow, so its temperature will increase and its entropy will increase, as we studied in the last article. So reading this out, no entropy transfer with work. There is no entropy transfer associated with work. For example, when a system delivers work to flywheel where energy is stored in fully recoverable form, the flywheel molecules are simply put into rotation around the axis in a perfectly organized manner, and there is no dissipation and hence no entropy increase of the flywheel. The same can be said about the work transfer in compression of springs or in raising the weight by a certain height. There is no entropy transfer with work. If the work is dissipated adiabatically into internal energy increase of the system, there is an entropy increase in the system, but there is no entropy transfer to it. Okay, so this is here the entropy transfer takes place. So here no entropy transfer takes place. So with the work, no entropy transfer. Okay. When work is converted into heat, that heat is causing entropy to increase or increase for the system. So only work will not cause any entropy transfer. Okay, because it is not changing the molecular cause or molecular disorder. In case of flywheel spring, it is changing the molecular cause or molecular disorder in case of fluid when this work of shaft is applied to the fluid.